Hello everyone. I am Professor Amit Vyas, Computer IT Department from Dr. Spas Technical Campus. Today we are discuss about the topic is instruction cycle. So what is the instruction cycle? We can show that an instruction cycle is a one program is inside the memory unit of computer which consistent of the sequence of instruction. In the basic computer, each instruction cycle have consistent of following phase. It means each instruction cycle is one sequence we can follow. It means each instruction cycle is provide some instruction for particular one cycle. So, which instruction is follow for instruction cycle? First of all, fetch the instruction from the memory, decode the instruction. After, read the instruction from the memory if the instruction has been indirect address, and finally execute the instruction. These four phases is occupy the instruction cycle, which for fetch the instruction, decode the instruction, read the effective address, and if the memory is indicate the indirect address, and finally execute the instruction. This all the phase is instruction cycle. After step number 4, the control goes to the step number 1. It means if the execute instruction we can complete, then finally start the fetch instruction, then decode and execute. This cycle we can follow. This cycle will be followed. So the next is, this is some short explanation of the instruction cycle. First of all, we can show the one diagram. This diagrams of the instruction cycle. How can you explain this diagram in instruction cycle? Initial condition, sequence counter. What is the AC? AC means sequence counter. Sequence counter is 0. Then after process we can start. What is the AR? Address register. PC means program counter. So we can show the IR and all the short form. We can explain the previous example and a previous slide. So initial condition, sequence counter is 0. Then after program counter we can address of memory. Then after what is the MR? Address we can store the memory. Then program counter we can increase. Then after the memory we can goes to the IR phase. It means instruction register. Then instruction register having 16 byte. So 0 to 11. It means 12 bit we can address register. Remaining 3 bit will be opcode and 1 will be direct address or indirect address. So we can show that step number 7. It means D7. Register or IO equal to 1. It means the I. Here we can show that the address register will be 12 bit, remaining 3 bit will be opcode and 1 will be I. I means it is 1 or 0, direct address or indirect address. We can show the D7. D7 we can provide with 1 or 0. If the 1, then provide register or IO. If D7 equal to 0, then it directly indicate memory reference. If the 1, then goes to the register or IO. If the IO, then go to the 1 and 0 go to the register. If the 1, then execute the input. If the 1, then execute the input output instruction, and finally sequence counter is 0 and step is goes to the address register. If I equal to 0, then go to the register, execute the register reference instruction, sequence counter is 0, then go to the address register. We can always we can show that what is the register and IO in previous memory reference instruction. So we can not explain in details. So we can show the sequence counter is 0 and go to the address register. Now the D7 is 0, that time is provide the memory reference. In memory reference, we can show the I equal to 1 is indirect address and 0 will be direct address. It means 0 is indicated direct address and 1 is indicated indirect address. So if the 1, then memory can store the address, and finally address register is go to the execution, the memory reference and sequence counter is 0 and go to the address register, then direct address, nothing operation is performed and directly go to the address register which sequence counter is 0. So this is the explanation of the sequence. This is the explanation of instruction cycle. So the initial condition sequence counter is 0, then after go to the address register, then program counter is increased with address, we can store the memory and go to the instruction register. Instruction register is occupied, the bit will be 16, the 12 bit will be address register, remaining 3 bit will be opcode, then 1 bit will be I. I is indicate 1 and 0. If the 1 go to the register, 0 is go to the memory reference, then directly explanation he can show that. So this is the instruction register. Now the short explanation here we can show that if the D7 equal to 1, the instruction must be register reference or input output type. We can show that if the D7 equal to 1 with a register reference or IO, or D7 equal to 0, go to the memory reference. If the D7 equal to 0, the operation code must be 1 or another is 7. So no specify of the memory instruction. It means the D7 equal to 0, then go to the memory reference. Control the inspect the value of the first bit of the instruction which now available in flip-flop. So if the D7 equal to 0 and I equal to 1, and when go to the memory reference and instruction will be indirect address. We can show that if the D7 equal to 0 and I equal to 1, this is the indirect address, and I equal to 0, then direct address. So this is the short explanation. Now the next is if the D7 and T3 position, we can store the address, then D7 and T3 will be nothing. So what is the D7? This is the D7 and T3 means this is the T3 operation. We can show that here for T3 operation you can write. You can write the execute input output operation, then register reference instruction, memory, you can store the address, and finally direct will be nothing operation. So this is the short explanation you can write here. A register reference or input output instruction can be executed with the click associated with the time signal T3. This is the T3 signal. After the instruction is executed and sequence counter is 0 and control the return of the fetch instruction. We can show that all the process of sequence counter is 0 at T3 time, then process must be start in fetch instruction. It means starting with first condition. So the sequence counter is either increment or clear. So this is the process diagram of the instruction cycle. Now we can show that one short instruction. This is the instruction cycle. Fetch the instruction, decode, read the effective address, if the direct address or indirect address, and final execute. You can follow this flowchart of sequence counter initial condition is 0. Then after address register, program counter, and then D7 will be 1 and 0. IO register and direct indirect address and sequence counter is 0. So thank you all of you.